As the winter of Toronto has already come, it's cold outside, so many of us may take hot bottled water to the campus. And we found that no matter hot or warm the water we took, it is not very hot after we arrived at campus. This phenomenon is very interesting and caught our attention. Then we find that this circumstance is related to Newton's law of cooling. So what is Newton's law of cooling? Newton's law of cooling is a differential equation which is derivative of temperature equals to K times T minus Ts. Lowercase t represents time taken from the cooling, and uppercase T represents the temperature of the given object at time t. Ts is the surrounding or ambient temperature, T0 is the initial temperature of the object, and K represents decay constant. This equation tells us the change rate of an object's temperature is proportional to the difference of the object's temperature and the environmental temperature. Now, let's discuss this equation to get an expression for temperature in different possible conditions. We can write Newton's law of cooling as derivative of temperature equals to negative K times T minus Ta. And we can divide T minus Ta on both sides of the equation, and also multiply d lowercase t on both sides of the equation, and integrate, and solve the integration to get the natural log. And solve the natural log, we can get the absolute value of T minus Ta equals to e to the power of minus kt plus c1. And we can write e to the power of c1 as the constant c. To get the result, c times e to the power of minus kt. There are two aspects we can discuss. The first one is t is greater than or equal to Ta. We can get an expression for temperature, which is c times e to the power of minus kt plus Ta. And the second case is t is less than Ta. And we can get temperature equals to Ta minus c times e to the power of minus kt. Therefore, we can explain the confusing phenomenon mentioned at the beginning of this video now. Because the difference of the hot water temperature and the environmental temperature is larger than the difference of the warm water temperature and surrounding temperature. So the cooling speed of hot water is faster than the warm one. Therefore, after we get to the campus, the hot water has cooled down a lot, but the warm water cools down more slowly, so they become both warm in the end. In our daily life, there still exist a lot of similar problems like this that can be explained by Newton's law of cooling. Just go and find such interesting circumstances, and you will have fun.